Let us consider the graph on the picture and find the Hamilton path in this graph. Hamilton path must pass through every vertex and it must be once. So every vertex once. And we can find many such paths. Let us start with A. Then we can go through B, C, D, E. A, B, C, D, E. We can go another way. A, B, D, C, E. Or another way. A, E, B, D, C. So if we return to the first vertex, then it will be Hamilton circuit. So instead of this first path, we will write A, B, C, D, E, A. Start with A and finish with A. We can start in any other vertex. It is usually given in the problem where to start. For example, if you start with E, then we can go to B, D. You see, it is not a complete graph since there is no edge from A to C. So then to go through every vertex only once, we must change it a little bit. A, B, E, B, A, D, C, E. So this is the Hamilton circuit starting with and ending at E. In a complete graph, there is a line connecting every vertex with every vertex. Like this. So now we have a complete graph. Such a graph is called K, and depending on the number of vertices, here we have 5, we can n minus 1 factorial different paths or circuits. So in this case, n equals to 5, so we have 5 minus 1 factorial, or 4 factorial, or 1 times 2 times 3 times 4, 6 times 4, 24 different circuits. 12 different circuits, since another 12 are the same circuit written in a different direction. So in the most cases, it is the same. So the circuit A, B, C, D, E. A is actually the same as A, E, D, C, B, A. You will have in homework 2 problems for one of them, the different matters, for another doesn't. So actually it is the same circuit if we talk about the weight of this path, so if the graph. For some other problem, for example, traveling, and when the direction is important, so we start with AB or we start with AE. In such a problem, you have 24 different graphs. So if this is not important, this or this is the same, then you have 12 different graphs. If you're in the problems when you're considering weights and you decide which weight is better, then this is actually the same. Now let us consider a weighted graph. Every edge has an assigned weight, and we want to find a circuit with the best weight. So, for example, if this is distance or the price for traveling from B to D in some unions, then we want to find the cheapest way. And we have three algorithms. The first of them is a brute force algorithm, the most inefficient, but the most simple. We just list all possible Hamilton circuits. Hamilton's means we visit every vertex. Circuit means we return to the same vertex. So for 5 vertices, there will be 12 different circuits. We find the weight of all of them and choose the best one. We have 2 other algorithms. The most simple is nearest neighbor algorithm. Let us start with the vertex B and find the cheapest way using nearest neighbor algorithm. So the neighbors are actually all 4 other vertices. The distance to C is 10, to D 12, to E 14, and to A 18. You see that 10 is the lowest number, so the nearest neighbor is C. Then we're searching for the cheapest distance from C to any other vertex. We have 11, 19, and 14. 11 is the cheapest occasion, so we choose D. Now we came to D. We have actually 3 edges coming out from D, 12, 15, and 16, but we cannot take 12 because if we go from D to B, we will return to B and we will close the circuit without visiting A and E. So B must be the last step of the trip. So we cannot go along BD. We choose between 15 and 16. 15 is better, so we move from D to A. So we are almost done. The only vertex left is E, and we do not have to choose here. We just move to E, and then we return to B. To find the weight of this trip, of this circuit, we add all the weights. So BC is 10, CD, the weight of CD is 11, DA has the weight 15, AE has the weight 17, and the last edge EB weighs 14. So if you add these 5 numbers, you will get the weight of this trip, on this path. Let us find the circuit starting from A. Starting with the vertex A. From A, we have 4 options: 18, 13, 15, and 17. The best is 13. So we'll travel to C. From C, we can go to B, E, or D. 10, 19, 11. 10 is the smallest number. We travel to B and we add to our weight 10. From B, so A, C, B, we have the following options: D or E. We are not considering BA since it will finish our circle and it will not be Hamiltonian circle. So we choose between 12 and 14. 12 is better, so the next vertex will be D. We add 12. Then A, C, B, D, one vertex is left, and this is E. We travel to E and then return to A. The weight of DE is 16 plus 16. The weight of EA is 17 plus 17. The weight of this circuit is 68 units. So there is another method, best edge algorithm. For this method, let's make a sketch of our star, drawing only the vertices A, B, C, D, E. And here we start not from the vertex but from the edge, the very, very best edge in an entire graph. And this is the edge BC, which has the weight 10. The second edge must not be connected with this first one. It can be any edge outside. So in the other part of the graph, it can be BE or AE, doesn't matter. So we just take the best one. Occasionally the second best is CD, so it continues our circuit, but it could be any other edge. So the third best, so it was the first one, the second one, the third could be BD, but it is not, since it will close our circle before we visit two other vertices. Then the same with 13. We cannot take 13 since we will get 3 edges ending up in the same point at C. It is also not allowed. So in Hamilton's circuit, we visit every vertex only once. So let us search further. Then we have 14. 14 is the edge BE. This is our third one. Then from this point, actually, is nothing to choose. The only way to finish this circuit will be AE and AD. So then we will visit all 5 vertices once. Let us find the weight of the circuit. The first edge 10 plus 11 plus third was 14 and plus 15 and plus 17. It is also 67. And let us write down the circuit. So usually given the vertex where to start, writing down the letters. So if we have to start from B, we will write either B, C, D, A, E, B. Don't forget to finish at B. Or the same circuit can be written in the other direction. B, E, A, D, C, B. It's actually the same circuit. It has the same weight. So if we are asked to list the vertices starting from A, then we will write A, D, C, B, E, A, or in the other direction A, E, B, C, D, A. So the same numbers in the opposite direction. So when you use the best edge algorithm, you will get only one circuit, and the answer depends only from which vertex should you start to list this circuit, to list the vertices in the circuit. So by nearest neighbor algorithm, you can get different circuits depending on where you start. You see, by starting with B, we have got the weight 67. Starting with A, we have got 68. It could be that best H algorithm and nearest neighbor algorithm give different answer, or they can give the same answers, the same circuits. It's always different.